write out R value for you. So R value is 0.0802.
Is that just
206. So this equation have this unit have involved with a liter atmosphere, and it has mole and it has Kelvin. You see something? So it has 4 units involved with R. So because of that, whenever you are applying any calculation, whenever you're doing any calculation with this P equal to nRT, which is P equal to nRT. So whenever you're doing any calculation with this ideal gas law equation, you must convert P in atmosphere. Because the R value, gas constant you have, that has a unit which is in Kelvin, mole, atmosphere, and liter. So you put volume in here, must convert liter first. Put the value of pressure, you put in atmosphere first. Then you apply with this equation. That makes sense? Okay. And then let's see what next problem is. We got the volume first of 50 liter. Do we need to convert 50 to milliliter?
no?
Why not?
So it says in liters.
It said it should be in the liter, right? Because of the R value. So liter and pressure, look at that. He converted to atmosphere. Or it is given in the atmosphere, by the way, 17.1. And you're going to stay as it is. What if I have in torrs? What if I have in ideal gas situation? And pressure is in torrs. What are you going to do? Divide by 760, make it 2 in atmospheric unit. And last question. How do I know that I'll be applying ideal gas equation?
Just gotta know.
Second?
You gotta read the question and see what's given.
They're asking for the mass.
That's a one clue, very good clue. That's a very deep clue. Let's go more simple way, okay? There is no P2, P2. The simple way you can see that. Right? Only PB and T. It did not say P1, B1, T1 and others. So the other way, of course, when you see the mass, only way you can get the mass is from this N. Right? N equal to, what is that N means? Mass over molar mass. Remember that I talked about the M, different types of M, but this M could be smaller M too. Should not be confused with that, because different writer write in different way. So if you need mass in any circumstances and you have other values given and R values always going to be constant, do you need to memorize that?
Yes.
Yeah.
No.
No, you should have trust on me by this time, no?
No.
You should just know that number.
You should, that should be given for you exam.
Oh, sir.
Okay? Or you don't trust me yet.
So whenever we see that number given, we'll just know what to do.
Second.
So whenever that number is given, we should just know to use that equation.
Yes.
Okay.
Yes. So our value will be given in exam in the equation list for you guys, and then
Just gonna write it on the paper.
so then he got the n. If you got the n value, n equal to n, right? And in this problem, you need mass. So the mass equal to molar mass times, this is going to be n. Molar mass times n, right? Moles. So you got the moles. What is the mole unit? What is the unit of mole? Mole equal to, you see, mass, gram over gram. What is the unit? No unit. Right? Gram over gram is going to cancel out.
Yeah.
So must be no unit. Right? And have no unit. And then you multiply molar mass with a n, you get the mass. Okay? So how do I know molar mass? 35.2. How do I know that? The 35.2 he got for N. So this N in here 35.2. And then molar mass of, it's talking about the nitrogen, isn't it? So nitrogen is in the period table. You can calculate, which is 28.02. 02 times
14.
Hold on, how did you get this number?
because N2, 1 N equal to 14, right? So it says N2. You see the molecule name is N2, nitrogen. So nitrogen is 14.01
Right.
times 2. So 28.02. And that is the molar mass. And the N we got in this from this ideal gas law, which is 35.2. That gets you the mass of the molecule, huge number, 986 gram. Any question? Okay. So from this ideal gas law, if you rearrange it, putting the value of N, what is the N means? Mass over molar mass, small m over 2 capital M. And then if you rearrange it, you get this equation. The equation of molar mass. Let me take that out off so I get more space to write. So if you put the value of M over 2 capital M, then molar mass would be dRTP over P. dRT over P. This equation will not be given in exam for you guys in the equation list. So you have to memorize it. Can I give you a trick to memorize it?
Sure.
Molar mass equal to dirty P.
Dirty.
Sounds easy, everybody? Okay, it's fine.
Just say that.
You would remember it, but yeah.
Okay, so molar mass equal to dirty P, you memorize that way, okay? How about you can solve a problem? Solve this one. Oh, you have to go? Okay.
Yes.
You're on the pipe, don't worry.
What's the equation?
Oh, it is. Mass by the
So what she's doing, we might keep discussing. We need to calculate density. Whenever you have density problem, you might think that density has no equation except molar mass, right? So then you go for molar mass formula, write it up. You keep writing. And then let's see what we have. We have methane. Whenever I got methane, what I got in here? Molar mass, right? And molar mass is given, and then P pressure is given, temperature is given, right? So plug in the value. Look at that. Molar mass given. D we have it. Temperature we have it. P we have it, right?
What is D?
Oh, D you need to calculate. Yes.
Yeah.
So we got molar mass. We got P. We got T. Do we get R?
Yes.
Yes.
How do you know R?
It's a constant.
Constants always will be 0.08206.
All over.
Yes. Calvin cancel out, Sathmasjid cancel out, and then mass cancel out. You have gram per liter. When you get L, make sure you get it capital. Oh, no. Okay. So you have only left which density is gram per liter. Let me take it in a screen. Very good. You can see here. Everything cancel out except gram per capital L, gram per liter, which is unit of density, as you know that. So she got 1.72, and we got it. Yep. Thank you. You guys doing wonderful. Let's go last one.
Oh no, baby.
The last one.
Practice problem at home.
Last problem of today. What is it? Let's see what you have. We have volume, right? We have pressure. We have temperature. We have gram. We have empirical formula. How do you get molecular formula? What is the clue, guys, here? We talked a little bit today. So, what is the clue you have in here? How do you calculate molecular formula of octane? What is the clue? When you have a problem, you need to think of on certain point, right? What clue you have to figure out how to solve the problem? Remember we talked about that? Is a multiplier. What does multiplier means? Anybody? What does multiplier means? Multiplier. You could say x equal to?
You need two equations to solve the third one.
You see? Empirical formula mass. So molecular mass over empirical formula mass. So with this multiplier, you can solve this problem. Okay.
No,
Yes. Anybody can solve it.
if we have a mass,
Mass,
if we
yes.
have the n and mass, we can
Okay,
find
you guys
the n.
stay quiet with somebody else. Yes, sir. Go ahead, go ahead.
I'm thinking out loud. If I have the mass and then I can find the.
Okay, let me write out what you have, right? So I have a volume which is 500 milliliter, and I have a pressure which is 634 millimeter mercury. Let me convert it to 760 millimeter mercury over 1 ATM machine, and then temperature is 95 degrees centigrade plus 273 368 Kelvin, and then you have a mass which is 1.57 gram, and then what is molecular formula you calculate? Anybody, how can you solve this problem? Exactly. You find a density, and then what?
You plug it back into the equation for molar mass.
So let's see the density formula. So we know the molar mass equal to dirty P. Why are you so? You love it? Okay. Isn't it so easy to get molar mass? Because molar mass you plug in here, right? Look at the concept first. So from this, if you get the multiplier, right? That's all you need. You need that multiplier to multiply with the coefficient of empirical formula, isn't it?
Wait, so the MM over there with the X's, it doesn't mean molecular mass?
You can't see nothing.
Which one?
Right there.
What is
The
that?
MM.
Yeah, MM means
Molecular mass or
molecular mass.
Over what?
empirical formula.
Over empirical formula mass. So you just need this X, and then this X, if you know the X, you remember that X over empirical formula, right? So what is the empirical formula in here? Which is C4H8, H9. And this X will be multiplied with the coefficient. How do you get this X? From the molar mass. How do you get the molar mass? With it?
30p.
30p. Okay, let's put it here. So you get the P, you get the volume, and remember that to get this formula, your pressure have to be in atmosphere, and your volume have to be in liter. So you don't need. Do you need volume right now in here? You don't need right now, right?
No.
No. So you could have.
Find the
But don't you need
density.
to
To find the density.
Yes. So get the density. Density equal to
Mass, right?
what the density means? Mass 1.57.
Volume.
1.57.
Thank you. Over mass over
Volume.
Volume.
Which is
What's the
500
volume?
milliliters, which is 5,000.
500 milliliters. So get the density R constant value T given molar mass, and then give it the X. So let me show you in PowerPoint. So this is the density R T P. Then you get the mass, right? So if you get the molar mass, you plug it in here,
No, this one.
right?
Because this one you can move stuff.
Look at that. Molar mass over empirical formula mass. How do you get 57? Because 57, this mass of empirical formula, 57. So molar mass over empirical formula mass, that is 2. And this 2, you put in here C4H9, right? So multiply 2 with the coefficient, that's going to give you C18, C8H18. Okay. So then I'll stop here today, right?
Yeah.
Okay.
We have a